Good morning. We will start session 7 on chapter triangles. So in our previous session we understood about Pythagoras theorem and its converse, which are very important. So it is usually asked as state and prove Pythagoras theorem or its converse. So we'll start with the next exercise based on Pythagoras and its converse. First one is very simple here. I will just solve first two in that, and homework I will mark here. First main you will be solving third one and fourth one as a homework. The given numbers are 7 centimeter, 24 centimeter and 25 centimeter. The sides of a triangle are given below. Determine which of them are right triangle. In case if it is a right triangle, write the length of the hypotenuse. So what we will do here is, we will start finding the squares of the given sides of a triangle. 49, 24 square is 576 and 25 square is 625. We all know that hypotenuse is the longest side. So what we will do here now is, we will try that 49 plus 576 is equal to 625. That is equal to 25 square, right? Therefore, 7 square plus 24 square is nothing but 25 square. We just found out. We just tried 49 plus 576. Will it give 625? We wanted to check. That's all. So what we will write here is, therefore, the sides are of a right triangle. What is the length of the hypotenuse there? They have asked. Hypotenuse is 25 centimeter. That is important thing what they have asked. Let's see the next one. So second one what they have given here is 3 centimeter, 8 centimeter, 6 centimeter. So 3 square is 9, 8 square is 64 and 6 square is 36. It is not necessary that you have to add 3 and 8 only. Always add the smallest two number. So what we will add here is, we will add 9 plus 36, which is not equal to 64. Right? 9 plus 36 is not equal to 64. Therefore, the given sides are not of a right triangle. That's all. The given sides are not of a right triangle. These are asked in MCQs, children. Okay, such type of questions. We'll move to the next one. Again, we have to prove certain things here, and all these are done by similarity criteria only. So let's quickly begin with this. PQR is a triangle, right angle at P. So let me draw a triangle here now, which is right angle at P. So PQR is a triangle, right angle at P. M is a point on QR. M is a point on QR such that M is a point on QR such that PM is perpendicular to QR. Given in triangle PQR, angle P is equal to 90 degree. Simply you write here PM perpendicular to QR. To prove, PM square is equal to QM into MR. Now to prove this, children, we require two triangles for similarity, right? Now how do you know which triangle you have to choose? See, dot represents, I have already told you, into sign. PM square is equal to QM into MR. Now first of all, to choose triangle, see you can choose these two triangles but you might not get the required result. PM comes in between of this and this. Okay, understood that we have to either choose this triangle or this triangle. From that we understood. QM falls where? QM falls here means if PM is here and QM is here, this triangle you have to choose. It is must and should. Next is what here? MR. MR falls here. That means MR is coming in this triangle. This shows that you have to choose this triangle and this triangle for similarity. Okay. But if you choose this and this triangle for similarity, what do you get any common angle or something here? See, I will just write and show you first of all. Now we are choosing this and this, we understood. So when we choose this angle, we only know that this is 90 degree. Apart from that, do you know anything about here? No. What about second angle? Without second angle, double A criteria, we can't prove it, right? So always, whenever you have a right angle triangle with a perpendicular drawn, there is one trick. Now what is that? See here. Assume that this is a right angle triangle. Same thing I will write here. P, Q, R. This is 90 degree. Okay. So if this is 90 degree, children, what should be the measure of this and this? Either it should be 45 and 45. If it is an isosceles. Given triangle is not isosceles. So it can't be 45 and 45. So if it is not 45 and 45, what are the other two options available here? Combination I am asking you. So this can be 30 and this can be 60. Okay. If I tell you that this angle is 60 degree or this angle is 30 degree. For example, how do you find this angle? Actually, if you want to find 90 minus 60, how much? You get 30 degree here, right? Or in other case, if this was 90 and here we have to find, and this angle is given as 30 degree. How would you find this? This would be nothing but 90 minus 30, 60 degree. Would you get that? Okay. In all the cases, whatever angle you have here, an angle minus a given angle, only in the case of 90 degree, you get a solution. That means, suppose if I consider this angle as x, what should be this angle, children? This should be 90 minus x. Okay, fix it. Now in this figure also I am redrawing the figure once again here. Now I will draw a perpendicular. What is that perpendicular? M. So forget that 90 is here. 90 is for the whole. What are the angles what are visible to me now? One is perpendicular, which is 90 here and 90 here. 90 minus x and x. In the first case, what I will do is I will hide this triangle. What triangle you have now? You only have this triangle where you have 90 minus x and 90. So what is this angle, children, here? This is x. Now what we will do? We will hide this triangle. We have 90, we have x. So what is this? 90 minus x. See here, 90 minus x and plus x will give you 90. This is how you actually mark the angles in a given right angle triangle when one perpendicular is given to find the common angle. Very clear about this concept? Now let's start. So, proof. Now you understood which, because we are choosing two different triangles. If it is a part of a triangle, very easy for us to write double A criteria because we get that one common angle. Choose the triangles. I use this figure now. In triangle P, M, Q and triangle R, M, P. In triangle P, M, Q and R, M, P. So first of all, 90 degree angle we will write. Angle P, M, Q is equal to R, M, P is equal to 90. Reason, PM perpendicular to QR. Then 190 minus x angle we will write here. Which triangle we have chosen? PMQ here. So how do you read this triangle now? Angle MQP is equal to, now 90 minus x is here. Here which is 90 minus x is this angle. So how do you read? Angle MPR. MPR. That's all you can write. Need not give any reason because we already have that. Write third angle also if you want. Here angle is read as angle P and Q. Angle MPQ. Angle MPQ is equal to MRP. Right? Triangle PMQ is similar to triangle RMP by AAA criteria. I wrote off AAA because we want something in square. What if anything is missing? Writing sides is very easy, children. You need not look at the figure. Directly from this you can write. So here it is PQ. PQ upon RP is equal to, here it is PM, because whatever they have given we'll use here. PM upon MR is equal to, here it is QM upon PM. So we use these two things. PM into PM is PM square is equal to QM into MR. Hence proved. Main thing is identification of x and 90 minus x angle. Very clear? Now this works out only when you have two different set of triangle. If it is a part of a triangle, common side will be easily available. Let's start with the next one. Next one we have three different combinations here. So it's in figure ABC triangle. Okay. Let's quickly start with the third one. Third one, in triangle ABD, this is the given figure, BD, this is C, in triangle ABD, angle A is equal to 90 degree and AC perpendicular to BD. Now what all we have to show? We have to show that this is given, children, here. To prove AB square is equal to BC into BD. Next is AC square is equal to BC into DC. Next is AD square is equal to BD into CD. How to choose? Main thing is here, you can throw this all, but only thing you have to choose the triangle. How to choose? Again, let us find out. See what is there in the proving part, proportionality sides with respect to that triangle. AB is there, so this, I'll look at this triangle. BC is there, that means of course yes, I want this triangle only because AB and BC will fall in this. Next, BD is there. BD is whole. So it is understood that here I want triangle ABC and triangle, I'm just writing, later we'll see that, triangle ABC and triangle ABD. Part and the whole triangle I have chosen here. Look at this, AC square is there here. Now AC is again this part. BC is there. BC is this part. Of course, yes, this is the triangle. DC is there. DC is only this part. That means I need to choose two part triangle. Triangle ABC and triangle ADC. Right? Next, AD square. AD square is this side. Then it means this triangle I have to take. BD is there. BD is whole. So understood that I have to take triangle ADC and triangle ABD. Now did you understand how to choose the triangles here? Based on the given proportional signs, we need to first identify the triangles, only then you can solve the sum. Now here children, in this and this part and this part, we have a part triangle and a whole triangle. So it is very easy. You will get double A criteria because one common angle will always be there. What about this here, where you have two different set of triangles, smaller triangles? Again, 90-degree principle let us follow. Let us not imagine that this is there. So if this is 90 degree, I'll assume that this is x, then this is 90 minus x. Now the perpendicular comes here, means this is 90 and this is 90, right? So 90 x, 90 minus x, 90 minus x, and this is x. Easy for us to calculate. Let's quickly start. Proof. First one, I'll always choose a bigger one first, then I'll choose with respect to smaller one. I've written here only for our calculation. So in triangle BAD and triangle, which one we want? ABC. So in triangle BAD and triangle BCA. Children, even choosing, when you choose the triangles, you have to see that the vertices what you choose of one triangle should match with another triangle. Not compulsorily, but if you do that, it is well and good. So in triangle BAD and triangle BCA, I have chosen such a way that BAD, where B is angle x, A is angle whole angle 90, D is 90 minus x. Just see here. And triangle BCA, B is also x again, C is 90 here and A is 90 minus x, right? Choose vertices in that way only, always. So this triangle, let us write what all we know. So angle BAD is equal to angle BCA, that is equal to 90 degree, that we know, right? One angle is already over. Second one, do we have anything which is common between BAD and BCA? So it is B angle which is common in both. So I will say angle DBA is equal to angle ABC. Common angle. Third angle we always have to write. Angle BDA is equal to BAC. Third angle you can just mention here. So triangle BAD is similar to triangle BCA by AAA criteria. So BD upon AB is equal to AD upon AC is equal to AB upon BC. So AB, I will choose this and this. AB into AB square is equal to BD into BC. We proved the first one. Similarly, we have to start with the next one also. So what I will do, children, here is first one anyways I have done. Now you all know what to do. Now you all know how to do. Also I have mentioned the triangles also. Choose a triangle. See, always I made a point of writing the bigger triangle first and smaller triangle. Nothing, no rule like that. It's up to you. You can also write smaller triangle first and then bigger. Follow one thing. This is part and part triangle. This is again whole and the second part of triangle. Second two I am giving you for homework. These two proving part. Similarly, you know now because this is one sum what I have done. Previous one sum what I have done. It is almost similar to this. So please do this only once the figure is drawn. Rest all proof 1 you can give here. Next in proof 2 you can give, and next in proof 3 you can give. We'll start with the next one. ABC is an isosceles right angle triangle at C. So fourth one, if I consider right angle at C, so this is A, B and C. It's an isosceles and definitely AC should be equal to BC. Why? Because AB is the hypotenuse. Given in triangle ABC, angle C is equal to 90 degree. Okay. In isosceles triangle, AC is equal to BC. Okay. What we have to prove? To prove that AB square is equal to 2 times of AC square. Proof. So using Pythagoras theorem here, if I mention, in triangle ABC, angle C is equal to 90. Whenever you want to apply Pythagoras theorem, you should always mention what is 90 degree. Without mentioning 90 degree, if you say that square on the hypotenuse is equal to sum of square of other two sides, that actually stands wrong. It has to be mentioned what is 90 here. So with that respect, I can write AB square is equal to AC square plus BC square. Reason Pythagoras theorem. Okay. But what is AC and BC? Are they equal to each other? AB square is equal to, I will write here, AC square plus AC square. Reason AC is equal to BC. AB square is equal to 2 times of AC square. Fifth one, what is given here? ABC is an isosceles triangle. So ABC is an isosceles triangle with AC is equal to BC. So AC is equal to, or we will BC. Given in isosceles triangle ABC, AC is equal to BC. Along with that, they have given AB square is equal to 2 times of AC square. What we have to prove? To prove that ABC is a right triangle. That means, how do you prove that a given triangle is a right angle triangle? That's only by converse of Pythagoras theorem. Proof, there are several methods here for this, some children. I'll use one of them. I'll use the given AC is equal to, we'll write which triangle first. In triangle ABC, AC is equal to BC, given. Squaring on both sides, because we want the answer in terms of square. Squaring on both sides. So this will be AC square is equal to BC square, right? So what we will do now here is add AC square on both sides. Why it should be AC square? Because it is something we have 2 times of AC, that's why, on both sides. So this is AC square plus AC square, BC square plus AC square. Now don't say that BC square also is equal to AC and here also same thing. Don't do that. This is written as 2 times of AC square is equal to BC square plus AC square. But what is 2 times of AC square is equal to AB square? AB square is equal to BC square plus AC square. Reason, 2 times of AC square is equal to AB square. Now this is nothing but AB square is equal to BC square plus AC square. Square of the hypotenuse is equal to sum of the squares of other 2 sides. That's why, if that is there, then by converse of Pythagoras theorem the triangle containing these sides contains a right angle and it is a right angle triangle. Therefore, ABC is a right triangle at AB square is the hypotenuse at C. This is the final solution. Hypotenuse square is AB square, opposite angle is C, and that is 90 degree. So we'll see the next one now. We'll start the next one. Sixth one. ABC is an equilateral triangle with side given as 2A. So each side is mentioned as 2A. Find each of its altitude. An equilateral triangle can have how many altitudes? 3 altitudes. But what I do now is I only draw one altitude here because not required. If I draw one, assumed and understood that the remaining 2 altitudes are also equal. So given, or we'll start with the solution only, we have to find the measure of the altitude. Remember, how did we find the measure of the diagonal of a square? So that was known, right? It is nothing but root 2 of side. Similarly, you should always remember what is the measure of the altitude of an equilateral triangle. Asked in 1 mark MCQs usually. So measure of the diagonal of a square and altitude of an equilateral triangle is always a concept to be remembered. So let's do that. ABC is an equilateral triangle. So AB is equal to BC is equal to AC is equal to 2A. AD is the altitude. Altitude means we always know that it is 90 degree. Okay. So choose these 2 triangles and prove them they are congruent, and prove that because it's an altitude. Though we know when we draw an altitude it's an equilateral triangle divides equally, but still we need to prove it. In triangle ADB and triangle ADC. AB is equal to AC. Equilateral triangle, they are equal. AD is equal to AD. Common side. Then angle ADB is equal to angle ADC is equal to 90. Reason AD perpendicular to BC. Which congruency rule, children? It is 2 sides and an angle, not SAS because it is not included angle. We have a 90 degree, we have a hypotenuse, and we have a common side. So it is RHS. ADB is equal and congruent to triangle ADC by RHS congruence rule. Right? From this I will tell BD is equal to CD. Reason CPCT. This implies BD is equal to CD is equal to 2A by 2. That is, whole is 2A, by 2 is nothing but A. So this is measure A and this also measures A. Now we know all the measures. Now I know this measure, only the height I need to find out. I'll do it this side, children, here. In triangle ABD, angle D is equal to 90. I have always told you, to use Pythagoras, we have to always mention the 90 degree, whichever triangle it is. So, AB square is equal to BD square plus AD square. Pythagoras theorem. Substitute the values. 2A whole square is equal to BD is A square plus AD square. 4A square minus A square is equal to AD square. AD square is equal to 3A square. AD is equal to root 3A square. AD is equal to root 3A. So what is an altitude of an equilateral triangle? Root 3A. What is that A? A is the side of an equilateral triangle. Provided A is the side means here, it is not actually side, it is part of this side here. This side. Suppose this side if you take it, it depends. What side is given, we always consider with respect to that. Into two-way what we consider. Diagonal measure is this always, children. Please remember. This is the measure of the, not diagonal, sorry, altitude of an equilateral triangle. So give the conclusion. Find each of its altitudes. If you want, you can just draw. This is one and this is another. The measure of each of an altitude of an equilateral triangle is root 3A. We'll solve one more and we will end with today's session. As the exercise is quite big, we will break this exercise into two sessions. So the last one for today's session, 7th one. Prove that sum of the squares of the sides of a rhombus. So if I assume that ABCD is a rhombus given ABCD is a rhombus, that's all. What we have to prove? Prove that the sum of the squares of the sides of a rhombus, that is sum of the squares of the side, AB square plus BC square plus CD square plus AD square is equal to the sum of the squares of its diagonals, AC square plus BD square. This can also be written as choose any one side, because in a rhombus all the sides are equal. 4 times of AB square is equal to AC square plus BD square. Sometimes only this statement is given. In ABCD is a rhombus, prove that 4 times of AB square is equal to AC square plus BD square. It's one and the same. 4 times of AB means all these are equal. In a rhombus all the sides are equal. Proof. So what we will do here is, now we know that in rhombus ABCD, AC is perpendicular to BD. We know that, right? So with this respect, angle AOB is equal to angle BOC is equal to angle COD is equal to AOD, that is equal to 90 degree. Choose any one part of a triangle whichever you want. Let me choose this AOB. So I will write here is OB, I'll take OA first. OA is nothing but half AC, right? Why? In a rhombus diagonal bisect each other, and OB I will write here it as half BD. Diagonals bisect each other. Okay, choose a triangle. In triangle AOB, angle AOB is equal to 90 degree. We know that because they bisect perpendicularly. So if it is 90 degree, AB square is equal to, this is 90 children, so this is hypotenuse, is equal to OA square plus OB square. Reason, Pythagoras theorem. Any one part you can choose here, this or this. I have chosen one. Substitute. What is OA value? 1 by 2 AC whole square plus what is OB value? 1 by 2 BD whole square. So this is 1 by 4 AC square plus 1 by 4 BD square. Take 1 by 4 common. 1 by 4 of AC square plus BD square. So set 4 this side. 4 times of AB square is equal to AC square plus BD square, right? That is what we have to prove. Now what is this 4 times of AB square? Let us first do this. It is nothing but AB square plus BC square plus CD square plus AD square is equal to AC square plus BD square. Sum of the sides of the squares of a rhombus is equal to the square on their diagonals, where AB is equal to BC is equal to CD is equal to AD, and AC and BD are the diagonals. With this we will end with today's session. There are few more sums which we will complete in the tomorrow's session.